I can only teach you so much Python in 4 hours here. And so we're just going to do the basics real quick. But hopefully it'll set you up to like really absorb stuff as you get into the tutorials you're doing later. So while I kind of run through the introduction here, if you haven't already, go to this URL, which I also put in the Slack channel, and download it. There will be a download link on that page. You can download it as a zip file. Yeah. And this is about to leave the screen, so I'm sorry. So if you haven't got this, maybe your neighbor, you can get it from your neighbor. So first, introduce myself. My name is Matt Davis. I have been coming to SciPy for, I think this is the 10-year anniversary of the first SciPy I came to. And I've been using Python for even longer than that. I'm Jiffy Club online, so if you want to send me an email or look me up, use Jiffy Club. Matt Davis is too common a name to use on the internet. And you can, this is my blog too, but I hardly ever post anything there. But it has stuff about Python. I also want to introduce our helpers. We got Carol and Maddie up here in the front. They're going to be helping out as we go around. Maddie, I apologize, I don't know what you do, but Carol works on Jupyter itself. So pester her with questions. NumPy? Sweet. So we got some sweet experts up here. So ask them questions. And please flag us down for help at any time throughout the tutorial. As I'm talking, if I do something that you don't understand, if I do something magical, if you have a question, interrupt me, yell at me. You don't have to be super polite and sit there with your hand in the air. You can interrupt me, shout me down, please. So you're all at SciPy, so I'm guessing you have some understanding of Python and an eagerness to learn it. So I don't think I need to motivate you too much here. But I do want to talk a little bit about kind of Python, its broader ecosystem. This slide is from a keynote given here 4 years ago by Jake Vanderplas, kind of talking about what we call the ecosystem of scientific Python. Stepping back even from this, there is the Python ecosystem, in its entirety, which includes things like web technologies and systems programming, in addition to the scientific part of it. I work at a health insurance company where we use Python for everything. So when you go to our website, Python is running to give you that website. And our data science team is using these tools to do their work. And all of the data transformation stuff that I work on is using Python. So it's really just a gigantic ecosystem where you can do almost anything. And when you get into the scientific ecosystem, there's this is going from at the bottom, the kind of core out to more specialized libraries. So there's Python, IPython and Jupyter, NumPy down there in the core. Then you get into things like SciPy, which has a lot of numerical routines, matplotlib for plotting, pandas is a tool for tabular data. So a lot of things you would do in SQL or Excel, you can do with pandas. And then it gets out into more specialized stuff. And kind of at that top layer, AstroPy is astronomy-related stuff. SunPy is solar astronomy-related stuff. And when it says there are many, many more, that's not an exaggeration. There are just zillions and zillions of domain-specific Python libraries out there. So no matter what field you work in, almost certainly there is somebody else out there already working in Python in your field. So welcome. I think you're going to find out that there's this is a great community with people already working here in your field, and I'm really excited for you to jump in. I want to get to know you all a little bit, so just kind of, we can do quick shows of hands here, how many of you are academics? A few people. How many of you work in the public sector? One. And how many people work in some kind of industry? Okay, very interesting. How many of y'all would describe yourselves as scientists? Okay. Engineers? All right. Something else? What do we got? Data analyst? Administrator? Anyone else? All right. Yeah? Model developer? Interesting. Thank you. Cool. Trying to think of how many of you have used Python already somewhere for something? Okay. Good bit of you. And how many of you literally never typed a line of Python before? A few people. Awesome. Cool.
Don't be nervous. Python's a wonderful language for learning.
That was the entire presentation. So now we're gonna get into things. I'm checking my notes here. So in the repo, there's an instructor notes file if you want to cheat and read what I wrote to myself. Cool. Okay, I think we're ready to try to actually get into the Python. So we're going to, at this point, let me.
Is that MD file, the text file? This is instructor notes.md.
Yep. Yeah, it's a text file. That MD is a markdown file. So you could go to it in the GitHub repo and it'll be rendered in a pretty way. So markdown is a text format that can be converted by a set of rules into HTML and other formats for kind of pretty printing. So I'm going to show you kind of very quickly what I'm doing, and then we're going to spend a few minutes with me and Carol and Maddie making sure you are all in this state too. So I'm at a command line, and I'm in the directory from the repo called SciPy 2019, Intro to Python. And when I list the files here, we see a couple of .ipynb files. Those are IPython notebook files that we'll be working in. And then there are some markdown files and one Python file. We're going to be using a library called IPython blocks as a learning tool in this session. That is defined in that IPython blocks.py file. It's a bunch of Python code, if you're curious to look under the hood, see how it works. And then the exercises have the exercises we're going to be working in, so you'll want to get those open. Again, you can do this on the web in the GitHub repo if you want. You can open those files.
Are we able to
No. So you'll have to see it up here. But let me change this.
Probably bump the font a little.
Yeah, and I can also change this color scheme to something more. Let me see if I can add a new. Yeah.
Color presets. On the bottom right.
Oh yeah. It's background. So let's see if I can get. Oops.
Is that easier to see?
And then I'm going to type Jupyter Notebook. So I'm not expecting you all to follow along right now. I just want to show you the steps, and then we'll come around and get you caught up. So I'm going to end up in a browser window that looks like this. So this is the Jupyter Notebook interface. And we'll be able to launch these and get to work in these. So we're going to spend a few minutes right now getting you all to this point. So let's do it. If you already have some familiarity with Jupyter and know how to do this on your own, fantastic. If you need help, that's what we're here for. So let's spend a few minutes on this.
And they're not gonna need the command line after this, or?
No. So yeah, we're not going to use the command line. So we can use like the Anaconda launcher if that's an easier way to get them there. Whatever works.
Okay, cool.
Carol knows everything.
I'm just the warm-up act.
No, for real, Carol knows everything. So ask her
I
ask her
don't.
questions. Okay, so I think we've got everybody here. You can open. Can we open these? That kind of worked. So I did these are links. Like you can do like right click, open a new tab on these. So it might be good to open up this exercises one and have that up. Either here, or you can do it through the GitHub repo over here. But we'll be referring to these exercises as we go. And there's a lot of fun actions you can do in here. I'm actually going to we're going to be doing this playing with blocks one. You don't need to do this, but I'm going to make a duplicate of this because I'm going to do like one set, I want to do what you're doing, and then in another one, I'm going to do like my demos. So I'm going to make a duplicate of that. Cool. And you can run multiple of these at one time, but if you click on one of these, it should open up a new tab that looks like this, leaving this one still open because you can have multiple copies of this open at once. So this is a Jupyter Notebook. Oh yeah, thank you. This is the notebook came out a few years ago and kind of changed everything. It's a browser-based interface to Python, and there's not only Python. You can have multiple. You can run kind of different backends for it. We're running the IPython backend for Jupyter, which is kind of written down as metadata in here, I think, the default kernel for it. So if you were to make a new one over here, you could set this up so that you had different choices under Notebook here. If, for example, you were an R user and wanted to use this as a front end for R or some other language, you could find out how online to set that up so that you could use the same interface as the backend for another language. But we're using Python. So that's what we're working with. And it remembered that from when I made these notebooks. You'll notice that there's a little bit of a mixture of code and text in here. So that's one of the sweet things about these notebooks is that you can mix code, text, images. Like you can make this like a web document and kind of make a whole story in here. So people have written obviously tutorials. People have written books in Jupyter Notebooks, papers. Like they're a fantastic tool for sharing stuff, and a great interface for like playing around. You can embed visualizations and stuff in here. They're a lot of fun and very popular. They're also great for sharing because you can take this text file when you hit save in here. By the way, you can use these things or just hit Command S on a Mac and it'll save it. But you can save it. It's a text file. You can put it on GitHub and then you can show it to other people. And as an example, I want to show kind of what happens when you put. Yeah, thank you. When you click on one of these, GitHub renders it, it's going to take a minute. Or you can take this URL, go to nbviewer.jupyter.org, paste in that URL and say go, and it'll download it and render it. So this is a great way to share stuff with people on the web. You can put it, if you have a GitHub account, you can put it in a GitHub repo, you can put it in a GitHub gist and share it. Or anywhere you can put it on the web, you can put in this URL and share it with people. And they have examples here. Cool. So back to running things in here. To run one of these code cells, you need to make sure it's selected. You'll notice there's a little color indicator around this box, and as I move the cursor between the boxes, it moves. This tells you which of these boxes you've currently got selected, and its color tells you about two different modes. When it's blue, I think we're in, what do we call this, command mode? I don't know. Okay.
Something like that.
So when it's green, you're editing the text in this field. And so I would think of this as like the editing mode. And then I hit escape and it turns blue. And so now I'm not editing it. You can hit return to get the cursor back in there, or click into it to get the cursor back in there. But if you use the keyboard shortcuts in here, you'll notice that they behave differently depending which of these two modes you're on. Speaking of keyboard shortcuts, when you're in the, what I'll call, I guess, the command mode, where the box is blue, if you press H, it'll bring up this keyboard shortcuts menu. And there's a lot of them, so I'm not going to talk about them, but there's a lot of keyboard shortcuts. You can work really fast and efficiently in the notebook. And if you notice me like magically moving things around or adding new cells in the notebook, this is what I'm doing. I'm using keyboard shortcuts. So to actually run these, you need to hold Shift and press Enter. So when I do that, a little number appears in this box, and that means that I've executed this cell. It has been run, and now I've done what's called importing these things from my Python blocks. Did that not work for anybody?
So is IPython blocks like a container that has several packages in it that importing?
So the question was, I didn't quite hear the word you used, but container.
Class, collection.
Yeah, so when you import something in Python, it's not always entirely clear like what was behind what you imported. It can be any of a number of different things. IPython blocks is a single Python file that's included in this repo. So you can go read in that file the definition of all of these things. But sometimes when you import things, it's importing it from like a compiled binary. Other times it's a package of Python files that you're importing from. It can be a little bit hard to tell, but it is, except in the case of probably some of the built-in stuff, like there's some analogous like file on your computer that it's getting this from. Cool. So everybody was able to run that. This proves that you actually have like a running Python back there that you're able to import this. Cool. One of the really sweet things about Jupyter is its help features, interactive help features. So we've got these things, but what are they? We can learn about them here in Jupyter. So I'm going to start with, let's say, this show color function. A couple of different ways we can get help about it. One is to put a question mark here at the end of this name and hit Shift-Enter. And it pops up this little window down here with the documentation and the signature. So this is an example of how you would call it. And then here's the documentation about it. It even tells you where it came from, where it was imported from. So to your question about like where did this get imported from? If you did this, it would give you that information. So we could call this. So it takes 3 inputs. They're going to be integers, 0 to 255. We're going to be working with colors a little bit in here, though you're not going to have to think super hard about it. To close this, you press this X. Escape also works. So let's actually try. Yeah, question.
Yeah, that's called the show color triple.
What's that?
Show color triple.
Didn't work? Okay. Did you download it a while ago? Okay. I added that fairly recently. You'll be okay. I think you'll be okay. You might have downloaded it before I added that. I was making last minute changes. Sorry. But if you take that out of, if you tried to, as long as you don't try to import it and you're able to import the other things, you'll be okay. I think. So when we want to call one of these functions, we put parentheses after its name. And then IPython has another help feature that can help us out here. When you've opened up these parentheses to call something in Python, if you hit ShiftTab, it'll pop open that same information about the kind of showing you the interface. If you hit ShiftTab, it goes away after a minute. If you hit ShiftTab again, it opens up a bigger window with more information. But this is really useful, like as you're working, to hit that so that you know, like, what are the arguments to this thing I'm calling. Show color, as you might guess, shows you a color. If you've ever worked with like red, green, blue tuples, like sets, like triplets, this is a way of specifying a color to computers, is to say this much red, this much green, this much blue, and then it mixes them together and it turns into a color. So that's a blue. So you can fiddle around with this, but you're not going to have to think about it too hard. Because of another really cool feature of Jupyter, it's tab completion. This colors object has a bunch of predefined colors on it. We can find out what they are. So talk about a little bit about tab completion. If you start typing something and then hit tab, Jupyter will try to complete it to something it knows about. So in this case, there's something called colors. So when I type COL and hit tab, it completes it out to colors because there was only one thing that matched COL. If there's more than one completion, it'll pop up a little window showing you the available completions, and you can pick the one you want. So to access the different colors on this thing, we're going to use a dot notation. So we're going to say colors dot, and then I'm going to start with, well, you could just hit tab here. And here are all of the different colors associated with this. And if we wanted to start to narrow it down a little bit, for example, to things that start with T, it'll update as we go. So this is a really great feature for kind of discovering what is attached to things. And we'll come back to that concept of attached in a minute. But you can think of these different colors as being like kind of attached as what we call attributes to this colors object. So we can look at that, for example. So this is a color object with red, green, and blue numbers associated with it. So this is a little convenience that we'll use in this session. Question?
How do you know if there's supposed to be parentheses at the end or not?
Good question. So in this example, I had to put parentheses to get it to do something. In this one, I didn't. I don't have like a super obvious answer for that. In Python and most programming languages, there are, I'm going to use the word object a lot to refer to these, like object kind of means literally anything in Python. And then to get into like further categorization of those things, there are classes and functions like block grid and show color that don't by themselves do anything. So if I type show color without the parentheses, it tells me it's a function. This is meant to be, what do we say, called. And then we can, sometimes you have to pass in information, other times you don't. And then it does something and comes back. And then there are other things which you can think of as basically data, what we call variables. And when you're working with variables, you don't have to do the parentheses because it's like a static piece of data. How you know which is which, like a priori, you kind of don't. You might have to inspect them a little bit to figure out, is this a function, is this a variable? That's totally fine to not know in advance and do like this, where I printed it out to get it to see like, oh, this is one thing or another. I don't know, is that helping? Okay. All right. Any questions at this point? We're able to call things, able to inspect things. This is kind of a feature of Jupyter, but if you type something on the line, it's like, it's not even calling anything. All I'm doing is typing something in the box and hitting Shift-Enter. It'll kind of echo it back to me. You can also put something on the last line of one of these cells, because these cells can have more than one line. And whatever is on the last line, Jupyter will display back to you. You had a question?
Yeah, regarding the syntax of this data, where we can find it the basic.
Good question. So the question was, where can we find like the basic syntax of Python? We'll go through it, but docs.python.org is going to be your go-to for information about Python. The README of the repo has a bunch of links in it, including links to this. So start here.
What you have access to.
All right. So we're able to look at the colors, and this, if you have the show color triple function, you can pass in the colors from the colors dictionary directly to that, and it'll do the same thing where it shows you what color it is, in case you're curious. But we're going to start working with the block grid and making our own variables. So let's look at the block grid. So I hit Shift-Tab to get this window to pop up. And so it's telling me what information I need to pass to block grid in order to interact with it. I need to give it a width and a height. There are also arguments for changing the color that the grid starts with, what size, whether it shows lines dividing the different cells of the grid. We're not going to play with the block size and the lines in this session, but if you want to get fancy, go for it. And there's more detailed information about here, for example, telling you whether what you're passing in is an integer or some other type. This syntax here, where kind of noting the difference between height and fill here, height doesn't have kind of a, well, let me start with fill. This means that fill has a default value of 0, 0, 0, which is black. So if you don't give it an argument for fill, you'll get back a black grid. It will use this default. Height doesn't have a default, so you have to specify a height and a width. So this is kind of telling you what's required, what's optional. So if we do 5, 5, we get back our grid of 5 by 5 grid of black. It is there. So he asked about the data type of width and height. It's annotated down here under parameters, width integer, height integer. So this docstring is optional for the person who writes the code that you're working with. And so it can look different, be non-existent in different places. So your mileage will vary with this docstring. Hopefully whoever wrote whatever you're working with was nice and put good docstrings in there for you to give you this kind of information. What are the arguments? What type are they supposed to be, and so on. If you end up writing code for other people, please be nice and put that information in the docstring when you learn how to do that. It's very useful for this kind of thing. So this gave us a grid, but we want to get a handle for this grid so that we can keep referring to it and do stuff to it. And we do that by assigning it to a variable with the equal sign. So on the left side of the equal sign here, you give a name to your variable. It can be whatever you want within Python's rules. It has to start with a letter or an underscore. It cannot start with a number. And it must contain only, well, this isn't strictly true, but most of the time you're going to see it only containing letters, numbers, and underscores. However, you can use, in Python 3, you can use any Unicode character in a Python variable name, so you're not limited to only letters, characters, or letters, underscores, and numbers, but keep it simple, letters, underscores, and numbers. We'll do 5 by 5. So, and I'm going to pass in a different color because I want to fancy it up here. I'll get to your question in a sec. That sounds nice. And this time it didn't show me the grid because it went into this variable, but I can now refer to this variable. And if I put it in a cell by itself and run it, Jupyter will show it back to me. So you'll notice I used a different syntax for specifying the fill. I didn't have to do this, but in the same way that the docstring kind of shows what the fill equals, when you're specifying arguments to something in Python, you can optionally use a label for it. So I could have done width equals, height equals, and this would have done the same thing. When you don't specify these names, it's using the order of the arguments to match them up to what the function expects. And if you use the names, the order doesn't matter. It matches them up by name. This can be a nice way, of labeling what you're passing in, so you don't have to remember which one is the width and which one is the height, for example. You'll notice, so I re-executed these cells. You'll notice these numbers changed. These numbers keep track of what order the notebook was executed in. If you close the notebook and shut down Jupyter and reopen it, it won't remember having run all of this stuff, and you'll have to rerun it, and these numbers will change during those different sessions. Just a little bit of trivia, but this will help you keep track of what order you did things in, because you can go back up and rerun things up here, and just re-import new stuff and do stuff. It's kind of a good hygiene practice to when you make a notebook to, after you're kind of done, close everything down or restart the kernel, which you can do in this kernel menu. and rerun it from the top, like all in order to make sure it works, and you didn't like do something out of order or break something after the fact, like remove a cell that was important or something as you were working on it. And now that I'm thinking about it, I'm going to remove this stuff so it's taking up less space up here. Carol, note?
If folks are blocked by their security of their own system, and you're kind of stuck, come see me and I will show you a different way that you can do this with my binder. We just have that. So.
Okay. Did everyone hear that? Is anyone having trouble running this? Are you helping them get on binder?
Well, it's a pretty simple one-liner.
Okay. Okay.
From IPython blocks, import block grid, colors, show colors, show colors.
Yeah.
Is anybody not able to get to the Jupyter Notebook
There are a couple
interface?
of people who couldn't do show trip, color trip.
Okay, yeah. So
Because they're using a different version of
they might have downloaded it before I added that, like, because I added that like in the last week.
So you probably need to re-download
Yeah,
the lady over
yeah,
there.
we talked about it. Huh. Interesting. We'll come. It's not critical, so we'll come back to that. We can look at that later. So, questions? People not able to follow along at this point? Cool.
Yeah, we're gonna need some help here with the binders.
Oh, yeah. Pretty much.
Because the laptops are locked down.
We built it.
Yeah. So another fun feature of Jupyter is, like, as a web technology, you can run the backend for it not on your laptop, right? Like, you can run it on the cloud somewhere, or the servers like at your lab or wherever, and then get an interface to it in your laptop while you're in Hawaii. Like, so it kind of allows you to, if you have the help to kind of set it up, or you know how to do the setup yourself, allows you to kind of separate where your computation happens and where you interface with it. And Carol has helped work with a tool called Binder that allows you to do this with public repos. So if you go to, I think it's at mybinder.org. Yeah. So you could go to this, for example, and like put in the URL of the repo and start it up and like run it in the cloud, which is pretty sweet. All right, so moving on here. Our first exercise, which you may have already done, is to make one of these yourself. Get yourself a grid 5x5 of your preferred color. Everyone up on that? All right. So now we're going to start working with this. The kind of the utility of this tool, IPython blocks, is that we get to kind of work with it, change it, and visually see what's happening so that we know we changed the right thing. We can access individual bits of this grid using indexing. So I'm going to make a new variable called block, and I'm going to pull it out of the grid. And I'm going to make a change to it. So this syntax here, when I said earlier that Python objects can have stuff attached to them, this is kind of what I meant. These blocks, which are individual pieces of this grid, have an attribute attached to them. An attribute is something attached to something else that's like a data element. You can assign to it, you can make changes to it, you can read it, but it's more of a static data element than like something you call that does something. And then if I run this, and then look at my grid again, it changed. So a couple of notes about Python's indexing.
So block is not a copy of that 0, 0 spot.
Yep.
It's just a handle for that.
Yep.
So if I make changes to block, I'm making changes to that spot.
Yep. So that's a good point. I'll come back to that. So a couple notes about Python's indexing, which is what this is called. Python is 0 index. So the first thing in a Python sequence is at index 0. The last thing in a Python sequence is at index, the length of it, -1. And this isn't clear from this example, but this Python is usually, but not always, what we call like row major, meaning this indicates the row of the grid, and this indicates the column of the grid. And to the question over here, when I pulled this block out of the grid, I didn't get a copy that's identical to this block. I got an actual, I was attaching a name to that same block and then interacting with it so that when I pulled this out and made changes to it, those changes were reflected in the original grid. And this is typical of, again, it kind of depends on what you're working with, but this is typical of Python, where when you pull something out of a container, that's actually the wrong word for it. Like, you're not pulling something out of the container, you're attaching a name, in this case block, to a specific item in a container. So when you do that, if you make changes to that thing, that using that name attached to the thing in the container, you're changing the thing in the container. So it's something to be aware of and typical behavior for Python. So for a little bit of practice with this, exercise 2 is change the color of the block in the 3rd row and 4th column of your grid. And I'll give you 2 minutes or so to do that.
I just get a block grid object with not color.
All right, so a couple people brought up something I forgot to mention when I was doing my example. Here, I used parentheses to call block grid. Here, I'm using square brackets to do indexing. And the difference between those is basically to indicate those two different actions. When I'm using parentheses, it means I'm calling that function or class and saying, here is some data, like kind of do your thing, execute whatever you're meant to execute, and give me back the result. The square bracket is when I have some sort of container for other data, and I want to get a specific element of that out, or elements, as we'll see. So this square bracket notation is for give me some element of this container. The parenthesis is for calling something and getting back the result or having it do whatever it's supposed to do. So we wanted to change the 3rd row and 4th column, right? So tricky bit, Python is 0 index, so the 3rd row is at index 2 and the 4th column is at index 3. So 2, 3. So I changed the 3rd row, 4th column. Okay, so go on to exercise 3, which is changing the block all the way in the lower right corner of the grid.
Did you point out that Python is 0 based?
Yeah, yeah. Okay, So we had a question about, so the, I kind of told you about this block.rgb attribute, but if we wanted to see what other things blocks have, block is still a variable that I can refer to here. So again, I should be able to use tab completion. So if I do block dot and then hit tab, I can see all of the different methods. And methods are like functions attached to something, and the other attributes here too. So I can see what column and row this came from, for example, the blue, green, and red components of the color, or the colors in their entirety. So that block.rgb is black, for example. So our job here was to change the block in the lower right-hand corner of this. I'm going to show you a little shortcut for that. Actually, I'm going to show you two different shortcuts. So this is a 5x5 grid, so kind of the last grid is at index 4. And you can change its, yeah. So I can also change the color by assigning directly to an element. There's kind of no way for you to have known this except either by experimenting or like reading the docs or seeing an example. So like there's no reason you were expected to find this on your own or anything. This is just like, Python has a lot of flexibility built into it for the for you and for the people who are writing the libraries you're using. It pays to read the documentation, I guess is what I'm trying to say. Like, you know, if the documentation exists, if there's tutorials and stuff, like understanding, like the interactive nature of the notebook can show you a lot of how things work. But there's a lot of flexibility that people can implement in things. I didn't have to implement this as a way of interacting with the grid. So it doesn't hurt to read the docs and find out what the authors had in mind for you when they wrote it. So that's a little shortcut. Another feature of Python indexing is that you can index from the back of a container using negative numbers. So I could have changed this last block by also doing this. So -1 is the last element in a sequence in Python. And you can mix and match. So you could use -1 in the row index to get the last row, but use 0 in the column index to get the first column, for example, to get the last row in the first column. So it's not one or the other. You can kind of pick and choose along these different dimensions.
So it's -5, upper left?
So the question was, is -5 the upper left? And my answer is, why don't you do exercise 4 and find out? Oops. All right, so exercise 4 here was to change the second row, first column using negative indexing, just for fun. So second row, -4, first column, -5. Yeah. So the negative indexing is especially helpful when you have something, like have some reason to need the last so many items of a container, but don't necessarily know how long it is. Which may or may not come up in your line of work, but it's kind of a cool feature. It was when I came to Python from like IDL, this feature was like one of the things that like made me really happy, because I no longer had to like know the length of everything all the time to figure out how to index things at the end of it. All right, let me look at my notes here. All right, we are up to loops. So as often happens, you have a container of data, and you want to loop over every element of that data and do something with it. So that's what we're going to work on here. So Python's loop syntax, it has two kinds of loops, for loops and while loops. We're only going to talk about for loops because they're the most common kind that you'll use. And the syntax that you will often use, well, that you'll always use, is to say for, and then you pick a variable name. I'm going to say block in grid. So the for and in are Python keywords that like set up the definition of this here. Grid is after the in, you put the container that you want to loop over, the set of data that you want to loop over. And then this is a new variable. This doesn't have to, I'm reusing the word block that I used up above, but this has no relation to that. This is going to be a new loop variable. And it could have been any valid Python name can go here. And then I can do something with that block. So I can change its color. So I'm going to change it to black. Down here at the bottom, I'm going to echo the grid. So notice I didn't have to do anything, but when I typed, so there's a couple of things to note. There's this colon, ends the definition of the for loop. So you're, like the stuff on the left side of this colon is like the definition of the loop. And you put a colon to say, that's the end of my loop definition. When you hit return in here, Jupyter automatically put an indentation on the next line there. That indentation is mandatory in Python. Python uses white space to define its program structure. So when I go back over to like the left side on this, for the last line here, this is outside of the loop. So this last line doesn't get run until the loop completes. So you'll notice this. You don't have to think about it a lot in Jupyter because it will automatically put that indentation for you after you start like a loop block. You do have to think about it to go back out of the loop at the end. But this is really important. You'll probably run into an issue today where you leave something out of a loop that you intended to have in it, or the other way around. You leave something in a loop that you didn't plan to put there because you forgot about the indentation. So if I run that, changed all of the colors to black. A feature of IPython blocks is that we can watch this happening using a feature called animate on the grid. Don't forget the colon, the end there. And now I'm going to do the same thing. Change it back to dark cyan. And this time I'm going to leave off the grid bit at the end, and you'll see why. So we can watch it working here. This is another great feature of Jupyter, the ability to do that. So you can see it went over in row order. So it did the first row, the second row, the third row, and so on. All right. Anybody having trouble with the loops? How to include what? Ah, good, great question. So the question was, how do you write comments in Python? You use the hash symbol, the octothorpe. So anything after an octothorpe is a comment that Python will ignore. So you can put them on a line by themselves. You can put them after lines. great way to take notes as we go here. Excellent question. Should have said that earlier. Question?
Okay, some crews do editors where you put blocks of code in there and the results are on the side. So what happens if I want to run 20 lines? Like, you know what I'm saying? This will be hard to export.
Mm-hmm. Yeah, so the question is, she's used to kind of writing entire files of code and running them. I don't know, that's, Carol, you might have a better answer for this. What?
Yeah, I mean, well, there's two things. One is you can hit File and download as a .py Python file, so it's second choice. So it'll take your notebook and then download it as a normal Python file. So it won't be cells, it'll be actual code. People have different approaches. The notebook is really good for rapid prototyping. Like, I want to do a couple things, and then I might, like, a lot of times I will take my own code out of the notebook and put it in a regular .py file. However, one of the things that's really nice is as I'm developing stuff, the fact that I can use Markdown and links and hyperlinks and stuff in Markdown, I can kind of walk through my thought process of what I'm doing with a combination of prose and code and visualizations. And that's where it becomes advantageous over just a regular Python file. Does that answer the question?
Yeah, since you told me you can export it to the Python file, that throw it in Spider or something, that makes a little more sense.
Yeah.
Yeah, and there are some third-party libraries that will actually split it out into Markdown and Python. I don't know the name off the top of my head, but you know, some research and you would be able to find that. So yeah, I mean, people are using it in many different ways.
Yeah, Carol got at my workflow with notebooks there. Like, I use it in two different modes. One is prototyping mode, where I get into the notebook and will do something over and over until it works the way I want, and then I will copy and paste that over to a Python file where I save it and really like its long-term uses. And the other case is when I want to like intentionally make some sort of document that I'm going to share with people, especially where I'm going to kind of put it into like not a presentable format that I can share with people. And then in that case, I'm going to add in the text and links and images and so on. To the points about like making notes and comments in here, I haven't talked yet about changing the type of cell here. We've been working with code cells, but you can also insert, you can change the cell type. Markdown is the other one. You can look up the Markdown format, but it's kind of text. You can write plain text in here.
Oh. Okay.
And then when you shift enter on a Markdown cell, it gets turned into text. And there's a whole markup syntax that you can use here to make links and embed images and videos and stuff.
How do you change the type?
So in this case, I use the cell type. There's also a keyboard shortcut for it. I think it's so I just pressed Y and it turned it into a code cell, and then if I press M, no, not M. Okay, I don't know how to turn it back into, oh no, maybe it is M. Yeah, it was M. But it didn't render it. I have to actually do Shift Enter to get it to render it. All right, so moving on with our loops. We want to get fancier than changing, kind of doing the same thing to every cell of the grid. We want to, as we loop over the grid, do different things based on properties of the cells. So we're going to use if statements. So we're going to start off with the same header, and then write an if block. So let me check my notes. So in this case, I want to change the color of everything in the second row. Actually, well, this is going to be the third row, right? So a couple things to note. This if keyword starts off the if block, and then you have to have some sort of condition that Python will evaluate. When this condition is true, Python will execute the stuff down here. When it's not true, it won't. There are comparison operators in Python, so note that this is 2 equals signs as opposed to the 1 equals sign used down here for assignment. So 1 equals sign for assigning something to something else. We also saw this 1 equals sign when we were passing in the keyword arguments, where we said like height equals and width equals when creating the grid. But when you're comparing two things and you want to say, are these two things the same? You use 2 equal signs. There's also operators for greater than and less than and not equal and greater than equal and less than equal. A whole bunch of different operators you can use. So let's see what happens. Nothing happens for a little bit. Oh, there it goes. Okay. And while this was executing, we got to see for a little while that this was a star. This means that the cell was executing. And then when it turned into a number, we knew it was done. Any questions about that?
Can you use an in and list out more than one row?
You can. So the question was, could we do a comparison with multiple things, essentially? And you can. I'm just going to copy and paste this to demonstrate. So that was magic. I just used keyboard shortcuts to like copy and paste a cell.
How did you do that?
So when you have it selected with the blue, if you press C, it pastes it, or it copies it. And then if you press V, it pastes it. So I'm not using command copy or command V. I'm just pressing C and V by themselves. So copy to copy a cell, V to paste that cell below the currently selected cell. If we wanted to compare to multiple things here, Python has an in syntax. And then you have to give it a sequence of things to compare to. So we could do this. Another option. Okay. So exercise 6. Change the color of every block in the 4th column of your grid. Okay. Everyone, so we wanted to do the 4th column. Oh, it was already red, but it seemed to work. Yeah. Cool. Any problems come up with this? Questions about this so far? Cool. So the next bit is making these conditions more complicated. So sometimes you want to test multiple things, or we want to do catch multiple things in the check. Same thing. And we can do that with, there's kind of 2 main logical operators for doing that called or and. So I'm gonna copy and paste this again. I'm gonna go back to my row and say, I'm gonna do like the first 2 rows. And then I'll change it to black. So or means if either of these things are true, do whatever is listed here. So as long as one of them is true, and you can have multiple of these, you could have more ors over here. As long as one of these things is true, this will get run. And a little bit advanced, but this syntax where we did in up here was basically a way of doing the same logic. Cool. So exercise 6. Oh, wait, no. Okay. So I got a little bit ahead of myself here, actually. So that's or. So we'll come back to that. You often want to have more complex if conditions where you're saying, like, if this case, do this thing. If this other case, do this other thing. Or if none of those cases, do this other thing. So you can get pretty fancy with these. So let's start with that. And the syntax for this is, so the second condition that you want to list, you do with elif. I'll say if the row equals 2. And you can have as many of these elif blocks as you like. So there's one if block, one kind of if that starts off the whole set, the kind of this whole series of if checks. And then you can have as many of these elif statements. Elif stands for else if, as you need here. And then your last one, which is optional, is else. The elif blocks are optional too. As you saw before, you can have an if by itself. You can have if with elifs. You can have if with an else. You can kind of mix and match these. And because this is, correct me if I'm wrong, Carol, but because this is all one big if, it's only for each block, it can only end up in one of these outlets of this if, I think. Mm-hmm. Yeah. So even if the condition, the second condition ended up being true, if the first condition was true, only the first condition would get run. So if you have a situation where you want something to kind of get into both of those cases, you'd want to put them in different if blocks so that it got caught by both, because you're only going to end up in one of these. So if this is true, do this one, and otherwise, if this is true, otherwise, if this one is false and this one is true, you do this one. If both of these are false, you'll end up running this one. Cool. And then, okay. So let's do exercises 7 and 8. Since I showed you both of those things. And in case you're getting antsy, we're going to take a break here pretty soon. Okay, so I did the example with the and. So with the and, as you probably figured out, both sides of this need to be true. So if any one of the conditions combined by an and is false, you won't end up down here. The whole thing ends up being false. So any questions about ifs, else's, or an and comparisons?
So we'll go to the logical order here. If you're gonna say three conditions together with an or, right, so or and three conditions, does it stop processing as soon as it finds one that's true?
Yes.
Or it doesn't even bother looking at the true state values for the other stuff?
It's, I don't know, do you know? I think so, but Carol is the core maintainer here.
It will short circuit, so if you're using an or and the first one is true, it will automatically make the whole thing true. If you're doing an and the first one is false, it will also short circuit and say, no, we're not gonna be true.
You can also, if you need to build up kind of a more complex set of things, you can use parentheses to group comparisons. If you need to say like, and like one thing and this thing or this other thing, you can use parentheses to group those into like logical sets. Let's see. There were a couple things I wanted to point out. I'm sorry the screen is as small as it is, so there are seats like towards the front if any of y'all in the back want to move up closer. I don't think I can make this a whole lot bigger. Yeah. So feel free to move up to the front and pack things in. And the other point was just about this .col. When I wrote this, for some reason, I picked .col instead of .column. I should really add .column, but no big lesson there. But like the people who write the code you use don't always get everything right, and you just and Carol is laughing because we mess it up almost every time. So you. A couple of like follow-ons from that. Like I said earlier, sometimes you just have to read the docs or read the code to figure out what's going on. The tab completion, very helpful here. You can also, for a lot of libraries, go to like the GitHub repo. You could, for example, go to the IPython blocks GitHub repo and ask a question there. Use GitHub. You have to create a GitHub account, but you can make what's called an issue there and say, like, I found this thing that seems to be broken, or it would help me a lot if you did this thing. Be very, very nice when you do that, because open source library maintainers mostly do it for free in their spare time, and you don't want to like ask, I don't know, I'm trying to find the right ways to phrase this, but
The basic thing is don't demand stuff.
yeah.
Please, thank you. Normal courtesy goes a lot farther to getting a good response.
Yeah. That said, I personally love it when people give me feedback about the code I write. It helps me know that people are actually using it, which is wonderful because you don't often hear that and have no idea how much your stuff is used. So it can be very, if somebody shows up and says something nice and asks a question or makes a suggestion, it makes my day. So get out there and do that in very nice ways. Any questions at this point? We're going to take a break for 15 minutes, come back at 10:15, and we're going to get into some more advanced looping and different ways of working with like multiple parts of these grids that are a bit more efficient. And then get into functions before we close out. I do want to just kind of pause real quick and point out that like now that you know for loops and if statements, you have like all the power of computing at your fingertips. Like we're going to get into functions, and like you need to know a bit about data, like containers for data. But when you get down to like the nuts and bolts of what computers are doing for you, it's for loops and if statements. Like everything else is just different ways of organizing for loops and if statements. And so like, congratulations, like all of computing is at your fingertips now. So be back in 15 minutes. There's usually like a snack, and I don't know if we're coinciding with the snack time here because nobody told me when it was, but there may or may not be snacks out in the hall. Okay.
You saw some snacks? There's usually gummy bears and stuff too.
All right, let's get back to business here. What? Thanks, Cheryl.
No problem.
I'm glad somebody's excited.
I'm so excited. Because many things in Python you can do with 5 lines of code or less. So you are now empowered.
And we're going to get to some of the real power that some of you have been alluding to around like, how could I do this on multiple things very quickly? That's kind of where we're headed here, to like doing some of this stuff we've been doing in one line of code, which is fun. So let's get started here. I just had a question around what if we wanted to, and a couple of people have asked me kind of variants of this, like what if we wanted to loop over only the blocks in the 4th column? Or something like that, where we want to have a bit more control over the set of blocks we're working with. We'll look at a couple of ways to do that. We're going to start with Python's range utility. So this is a built-in function called range. And what this does is it gives you back numbers, essentially, starting from, by default, from 0. We're going to look at a few different ways to call it. So if I do range 5, when I run this, it has a fairly nice display, but it's not actually the list of numbers. This is because Python doesn't generate that list of numbers when I call range. This is something called in Python called a generator, where if I were to iterate over this, I would get the numbers 0, 1, 2, 3, 4. But it doesn't do that computation ahead of time to save time and space. It generates it as you loop over it. So if we want to see the actual list of numbers returned by range, we can wrap this in list. And this will put it into a Python object type that we haven't talked about Python's built-in types yet. We'll get to that. But one of the built-in containers in Python is called a list. And this will actually iterate over the range and store in a list all of the numbers that range generates. So range 5 means 0, 1, 2, 3, 4. So it's like, give me the first 5 numbers used for indexing. And you'll notice that it doesn't include that endpoint because we're starting with 0. You can, if you want, specify a start point for range. Actually, let's hit the old tab here. So there's a couple of different ways to call range, and we'll look at these. So this way, I called it with 1 number. You're specifying the endpoint, and 0 is the default start. You can also manually specify the start. So we can do like 5 to 10. And again, so that starting point is included, the endpoint is not. But the difference between those two numbers is how many numbers you're going to get back. So 10 minus 5 is 5, so we got back 5 numbers, 5 through 9, including 9. You can also, the last kind of variant is to specify a step size, which is how many to skip, or like how many to add each time. So here we're going to start with 5 up to 10, but not including 10 in steps at 2. So we get back 5, 7, and 9. So how do we use this in a loop, right? So let's do that example of, well, let me check my notes. Okay, so let's do an example of changing only a single row. And so now we're not iterating over blocks, we're iterating over these numbers. So I'm going to use the loop variable index. Actually, now that I think about it, a better name for this, I'm going to be iterating over column indices, say. So I'm going to call this column. And here we might, a couple of different ways of specifying this. We could type in the number that we want, like I was in my example, so like 5. Or we could use data from our grid so that we can make this a little more general, where we don't need to know how big the grid is. So if I want to iterate over every column in a grid, I can use grid.width here. And now, kind of going back to the earlier way we were working with the grids, I can say grid, I'm going to pick a certain row, say the row at index 1, and then I'm going to specify the column here, and I'm going to give it a color. Now this time we're not going to get to see the animation, so I'm going to show grid after doing the loop here and see if it worked. So it turned this row tomato. Any questions about how this is working? So here it's really up to you to think about how you're using this and kind of set up your loop in a way that works, that executes your intent there. So are you looping, like what dimension are you looping over, for example, and labeling things such that that is clear, and making sure you're using your loop variable in the right part of the index and so on. You have to think about that as you're setting this up. All right, so exercise 10. Use this question back there.
Question about the last example. So, column. In the last for loop we ran, column, it had an RGB property.
Mm-hmm.
But here it seems to be just an integer.
Yep. So that.
What is column then?
Yeah. So this is. It depends what you're iterating over. Essentially, is like what ends up in this loop variable comes out of the container that you're iterating over. So in this case, we are iterating over our grid, which is programmed when you use it in a loop like this to give you the individual blocks out of the grid in your loop variable. And this has to do with like the underlying Python implementation of this. When I wrote this, I programmed it in such a way such that when it's used in a for loop like this, it gives you the individual blocks out of there. Here our loop is over the range thing, so you're getting the integers. So whatever this is, however it's programmed to behave in a loop, governs what ends up in this loop variable. Range generates integers, so we're going to end up with integers in the loop variable here. So we're going to work with a new, bigger grid for the rest of this. So starting off to make a new one. And I wanted to illustrate that tab completion works here too. So when I start typing the name of one of the inputs for block grid and hit tab, Jupyter's got me with the tab completion there. wow, bigger even than, wonder if I can make this. A little bit. Maybe a little too small. There we go. And so to change the 3rd, 10th, and 18th rows, we can loop over the column. So this is kind of the same loop we had before. So I want to visit every column in these certain rows. A couple different ways we could code up the 3rd, 10th, and 18th. One is just to write this out. Copy and paste this a couple times. That'd be one way of doing it. Totally valid way to do it. We could also set up another loop in here over those numbers, those rows. If you're curious how to do that, I'm going to. So you could also just kind of hard code these things that you want to loop over into the loop variable, and then do grid 20. All right, any questions about range so far? Cool. I think you can move on to exercise 11. So we want to change, in this we want to change the lower left quadrant of the grid. So this area here. The last 10 rows, the first 10 columns. And in fact, the syntax for having a loop inside of a loop is going to be important for that. So you'll notice I have a level of indentation naturally for the loop, and then a second level of indentation for the other loop. And then when I want to leave the loops entirely, I have to go back through both levels of indentation all the way to the left. If I was to put this here, it would still be inside of the outer loop, even though it's not inside the inner loop. So one of y'all noted I did something magical and you didn't call me on it. When I commented these, I was using a keyboard shortcut. On a Mac, it's Command /. If you select a bunch of lines and then do that, it'll comment all of them for you. It'll also uncomment them for you.
That's a good tip.
A lot of whatever editor the notebook uses has a lot of the same keyboard shortcuts as VS Code. So I always try my VS Code shortcuts in here, and sometimes they work and sometimes they don't. All right, so let's edit the lower quadrant, the lower left quadrant of this thing. So now I need to think about both the row and the column. So I'm going to do a column loop. So this is the last 10 columns. So I'm going to do starting at 10 up through grid.heights. And then for column in range, I want the first 10 columns, so I can put 10 there. And then do grid row column equals colors.gold. Oops, wrong grid. I think that worked. And to think a little bit about the order this executes in, we could, I'm trying to decide if I want to show it, but, or animate it, but, you know, so it'll go out of this inner loop executes all the way through for every one loop of this outer loop. So it'll do first row, all of the columns, second row, all of the columns, third row, all of the columns. And so as many loops as you have here. This is something to think about as you start, if you work with like largish matrices of data, is that the number of loops executed here is the number, like you multiply these, right? So this is 10 by 10. So this was 100 elements of execution. So this line of code got executed 100 times because it was 10 times 10. And so that can be, nested loops like this can be a place that you kind of build up performance issues in Python. So it's something to watch out for and to kind of keep in mind the level of how large these things are. Because even if it's only 1,000 by 1,000, now you're executing 1,000,000 things, which can get slow depending on what it is. A nice feature of NumPy, which I expect many of you are going to go learn about this afternoon, is a way to push these loops into a different layer of execution where you're not encoding the loops, but you're saying kind of implicitly, hey NumPy, like do this thing to a series of elements in an array. And when you do that, NumPy executes that operation, often at a lower level, where it can do those loops much faster than Python does it. So let's look at that. We're going to learn about slicing. So this is where things get really magical. Well, not magical, but like awesome magical. And we can make some very abbreviated ways of expressing these things we've been doing so far. So I've got my grid, and I want to change some section of it a different color. Let's say I want to do rows 3 to 8 and columns 11 through 18. And I'll give it a color. Rosy brown sounds nice. All right, so let's think about what's going to happen here. Any guesses? What should I expect to happen? Remember, this is rows, this is columns. A little trick some of you discovered that I should have called out. If you hover over these cells, they'll tell you what the index of that cell is. So this row is 3, and then here is 8. Just like with range, that first number is included, the last number is excluded from this. So this is gonna 3:8 is gonna generate 3, 4, 5, 6, 7. So I'm expecting rows 3 through 7 to change color, and then looking at the columns from 11 through 17. So it's going to be roughly this area I expect to change color. Nice. slice. So these are called slices. And there's several different ways of expressing them. And they're all analogous to range. So this is a start and a stop. I'm going to actually illustrate a couple of these with range. The start and stop are both optional. You can specify neither, and this means like everything. You can specify one or the other, so 5th index all the way to the end. And I can actually run this. Or other way around, everything up to the 5th index, but not including the 5th index. Or a combination of those. You can even include the step size in this. As a third thing. So this start at 2, up to 8 in steps of 2. And kind of as you saw here, this allows you to express some pretty sophisticated things in a small amount of code. 1 line even. And not only is it a small amount of code, but when you do this kind of thing with NumPy, you're able to push the loops over your data down into a more performant layer of execution than if you were to write these loops out yourself. So a really cool thing to learn, which you'll learn more about this afternoon if you go to the NumPy tutorial. So the last exercise in this section is to redo exercises 10 and 11, but using slices instead of for loops. So no for loops, only slices. Questions about slices?
Scroll down to the bottom.
All right. So I mentioned this offhand, but didn't give you a demo. But if you want to do every element along a dimension, you can put a colon by itself to say that. And then cool. Gesundheit. All right, how's everybody doing? An appreciation of for loops, if statements, slicing. Feel like you could figure out how to, if you had an array, you could figure out which parts of it you want to work on using loops, using slicing. Cool. Questions? This point, we're going to shift gears a little bit into functions now. So a good time to stop and ask any questions you have about anything we've covered so far. All right. Let's talk about functions then. So we've been using, we haven't been using too many functions so far, but range is an example of something, a function. It's a set of packaged code that you then call to do something. And Python has a number of built-in ones. IPython blocks has built-in ones. It's kind of how you as a developer of something you want to reuse, it's how you package it to get reused, or how you share it with other people to share some functionality, instead of saying, I mean, the alternative is like sending them a bunch of lines that they copy and paste into something. Often that functionality you want to be configurable. You want to be able to say, like, I've coded up this procedure. Now I want to be able to run it across different data sets, for example, without having to like change a bunch of variable names, that kind of thing. So we're going to look at how to do that. So I'm going to write a couple of example functions. I'm going to just copy this one out of my notes so we can talk about it. This is a Fahrenheit to Celsius temperature conversion. So functions start with this keyword def, a space, the name of your function. Same rules apply here as apply to variable names. Can't start with a number, letters, uppercase and lowercase. Numbers are allowed as long as it's not the first character, underscores. Somebody asked me earlier about like why block grid has capitalized letters and like show color triple doesn't, which is a great question. Those are conventions. Like Python is not enforcing any particular rules about how you name your things, but there's a very popular style guide for Python called PEP8, PEP8, that you can look up, that suggests naming things with particular styles so that we're using a common convention across Python that makes it easier to interpret other people to read your code and kind of make guesses about what your code means based on how you named and styled things. So IPython blocks follows PEP8. And so block grid, which is a class, is named with capital letters. And I'm not going to go into classes in this, but something for you to look up later. And then functions are named all lowercase with underscores separating the different words in the function name. And that's straight out of PEP8. So after your function name come parentheses, and inside the parentheses you list out any inputs your function takes. Your function doesn't have to take inputs, in which case this would be an empty set of parentheses. And then a colon, just like with for and if, a colon says this is the end of that, this is the end of like the definition, the header, so to speak, of the function. The following lines are going to be the contents or the body of the function. Note the indentation, same as with for loops and if statements. The body of a function is indented. For loops and if statements inside the function will be further indented. And the function ends. If I was to call this function here, for example, or put something here, like this would be outside the function. So going back to that outer layer of indentation ends the function. This return keyword is important because this is how you pass data back out of a function. It's optional. You don't have to put a return in a function, but if you don't, nothing gets passed back out. Sometimes that's what you want, and that's fine. But if, in this case, we want the Celsius temperature to come back out, so we use return. So we can call it. We get back a number like we expected. Yeah. Questions so far? Just as another example, I'm going to implement like an isEven function so that we'll have to implement a little bit of logic inside of here. So quickest way to check if something is even is to use the modulus operator, which is a percent sign in Python. If that's 0, return true. Otherwise, we'll return false. So you can have multiple returns in a function. You have to be a little bit careful about that because you can make it so if you put the return in the wrong place, you can make it so that parts of your function are never executed because your function returns at an earlier part. So watch out for that. But in a condition like this, you want to return something in one case, something else in another case, and it's totally fine to have multiple returns in there. And then note the extra level of indentation we put here. True and false are built-in Python keywords. These are Boolean data types. So far, we've seen a few different data types so far without explicitly talking about them. Mostly numbers. So all the numbers that we typed out when we were indexing the grids, for example, were integers like this and this. We finally met an example of a floating point number. So if you put a decimal in a number, it turns into a floating point number, which are different than integers. Now we're seeing these Boolean types, true and false.
Does elif work there also? Elif on that bottom return?
Yeah, if you wanted to put
It's not necessary.
else here, you could do this also.
Put elif.
Well, elif, if it's not equal 0, for example.
Okay.
Yeah, I mean, it depends on your logic. Oops. In this case, there's not,
Else is not required.
yeah, like it's either that case or it's not. So either it'll end up in, either it'll stop here or it won't go in there and it'll return here. So different ways of laying that out. I haven't mentioned it yet, but if you ever want to display something not on the last line, there's a print function in Python that will display it. Questions about functions? I said earlier that with our for loops and if statements, you had like all the power of computing at your fingertips. That was true, not a lie, but it's really tedious if you have to type them all up over and over and over again. And functions are the tool, the kind of fundamental tool that allow you to package up that logic, the for loops and if statements, into little components that you can apply again and again to different sets of data without having to like encode all of that stuff yourself. So,
Quick questions.
yeah.
On the for loops, before we were using dot animate to see the results from each iteration.
Mm-hmm.
Is that something that is unique to whatever we were using? Okay, so it's not, we just do that on the for loop.
Right, good question. So the question was that dot animate feature. That's not something available on any old thing in Python. That is a feature of IPython blocks. So only the grids will have that feature.
And are we going to do whiles?
I am not planning to show while loops. You can look it up in the Python docs. So we are ready for you to do a function. exercise 13. Write a function. So we're going to go back to the grids, to IPython, to the grids, but you're going to write a function that takes some grid as input and returns a new grid that is the same size and shape as that input grid, but has the colors inverted from the input grid. Let's talk about that color inversion for a quick second. What does that mean, to invert a color? So I'm going to just pick a color here. Go back to my... all right. What is the inverse of this color? Let's think about that a little bit. Yeah. So people are suggesting 255 minus this value. And the way I kind of start with this is if you have black, you should end up with white. And if you have white, you should end up with black. So how do you encode that? So here, I want to do 255 minus 12, 55 minus 123. And these numbers should never be more than 255, so you shouldn't have to worry about this rolling over into negative territory. Right. So that's the inverse. And when you're working with blocks, let's see if I still have a block here. Yep, there's a block. These have red, green, and blue attributes that give you access to the different components of the RGB color of this block, or you can use the RGB tuple directly. So a couple of different things there that'll be useful as you implement this function. So again, you're going to take a grid as input. You are not going to change that grid. You're going to make a new one with the same properties, but change the color to be the inverse of the input. Trade-offs again, like there's different ways of doing it, but okay. So keep going here. So it turns out I'd completely forgotten about it, but this fellow found the copy method on grids, so you can do grid.copy and get a copy of it. I didn't even know I did that. In case it's not clear, I wrote IPython blocks, so if you have any complaints about it, it's my fault. So let's go over the grid and invert the colors and assign them. Let's see. Does that make sense? Question back there. What does block here? This one? Yeah. So the question is what is block here? So we're iterating over the grid, the input grid, And so this is going to give us one block at a time from the input grid. And then we're going to use that to get the corresponding block out of the new the new instance we made of the grid, and then modify it to be the opposite of the attributes on the original block. So the block is from the input grid, and then new block is the corresponding block from the new one we made that we want to modify. Yeah, so this is helping us get the corresponding block, the block with the same position in the new grid as this block in the old grid. So another way of doing this would have been to use range to loop over like the grid width and height and then pull a block out of each. Looks like Carol has some.
Yeah, I was just gonna say, it's a pretty common Python when you use in, that it's an item in a collection. So a grid is a collection of blocks, so one block would be the item in the collection. Makes sense?
With the power and flexibility of Python comes the option of many different ways of doing this. I can think off the top of my head of like several different ways I could do this. Again, none of them are really better than others. There's different trade-offs. Usually I'm going for readability and like kind of the simplest thing that is quickest to read. And sometimes that means getting a little bit fancier. Like my preferred way of doing this would probably involve getting a little bit fancier and using Python zip function, for example. I don't want to get too fancy in front of you all though, so I'm trying to keep it fairly simple here. But know that happens. While I mentioned earlier like doc strings, so I want to show you how to write those. They're a special kind of comment that goes after the header of your function. This triple quote syntax is a way of making multi-line strings in Python. When this multi-line string is right after the header of your function, it's a special thing called a doc string that gets attached to the function in perpetuity, and IPython, Jupyter, can find it. You could write a comment directly above this function, but then Jupyter wouldn't find it because it wouldn't be magically attached to the function by Python. So we can put it here. And what you write out, there are styles for writing these that you can look up. There's like a NumPy doc style. There's a Google doc style for writing these. There's the like default Sphinx way of doing it, and I'm not even going to explain what Sphinx is. It doesn't like the IPython blocks, the ones you've seen, are documented in the NumPy doc style. As an example, I think it's very readable. If you pick one of those styles, there are tools, Sphinx, that will convert, will build websites out of this documentation and be able to render these doc strings into HTML if you use a specific format for the doc string. That's getting way ahead of ourselves, though. All I want you to think about writing here is something that helps people understand what your function does in plain English or your language of choice. So I'm going to write takes an input grid and returns a new grid of the same size and shape with colors the inverse of the input grid. So try to keep this high level, like help people understand what your thing does. You don't necessarily need to go into how it does it unless that's important for your people, for the users to know. If your function changes the input, this is a good place to tell people that. Anyway, let's see if this works. So I have grid, invert grid. It does not work. Because God, past me. What were you thinking? Okay, that looks right. Whoops. You'll notice here that I didn't include the block size in my new grid here, so that didn't work. Well, it worked, but it changed the size, so it's not exactly the same. So really what I should probably do is grid.copy here. That's better. So when I was making a new grid, I wasn't including the size, the block size from the input grid. I was leaving it as the default, which is bigger than what I had programmed this one to be so that it would fit on my screen.
It looked to me like you had it set it to be the same, whatever your input was.
So I was copying the width and, sorry, when I say size, I mean the size of, I was meaning the size of these individual blocks, not the width and the number of blocks in the grid. Yeah, so you can control the individual size of these blocks in pixels, or I think it's pixels. And to display this bigger one, I made them smaller so that it would fit on my blown up screen. So any functions, or sorry, any questions about functions at this point? Yeah. So were you doing block.column like I had? Yeah. As we have discovered, past me wasn't really making the right decisions and called this .col instead of .column. I regret that. I should change that. I could have both. Any other questions about functions so far? All right. I wanted to pause real quick and call out a faux pas I made earlier. I called you all guys. I'm sorry. I don't do that, except when I do. So I'm sorry. It's not inclusive, and I try to say you all, y'all, folks, things like that. So where do we want to go from here? We've got half an hour left. We could continue doing functions, kind of the last, there's a couple more exercises we could do. It might be interesting to, I think, give you, have you work a little bit with some of Python's common built-in types a bit more explicitly than we have done so far. So I think we're going to skip exercise 14, and we'll do exercise 15. But in order to get there, I need to show you some examples of, this is going to get pretty involved, so we may not get all the way through finishing it, but I want to show you a little bit of Python's built-in types, so if you see them later, it's not surprising, and probably leave a few minutes at the end for you to ask questions that are unrelated to these exercises, if you have any. So let's start looking at some of Python's built-in types. We've seen so far Booleans, true and false. So there's true, false. There's a special value called none. I don't know how to explain it except that it's none. I'm trying to put two spaces and then my computer thinks that a period goes there. computer, you're wrong. So none is like kind of the value used in Python for like not set, essentially. So it's often used in places where you have an optional value, for example, that's for some reason not set to another value, and you want to like let them have some default behavior. It's also the value returned by Python when you don't put a return in a function. It'll implicitly return none. What's that? You can use it as a placeholder for different things, yeah. That's like the most common place it shows up is like something goes here, but it hasn't been specified, or you don't have to specify it. We've seen integers, 1, 2, 3, and we briefly saw floating point values. They can behave subtly different than integers, so it's something to call out, and to know which thing you're getting. Let's see, strings are another kind of default built-in thing, so enclosing something in quotes makes it a string.
So I have a question about the booleans.
Uh-huh.
Did I get lucky, or does it really work when I use 0 for false? In place of false, is that allowed, or is that?
So the question is about using 0 in place of false, and by analogy, like something like 1 in place of true. There's a couple layers to that. In Python, false is in fact equal to 0, and true is in fact equal to 1. You can use true and false in the place of integers. But at a slightly higher level, Python has this concept of like truthiness for everything in Python. And so how that ends up resolving to true and false can vary. But for numbers, 0 is false. Any other number is true. For sequences like strings and lists and dictionaries, an empty one is false. A non-empty one is true. And then for other things, the behavior can be undefined or varied. So your mileage will vary depending on the thing you're working with. As the author of like a Python class, you can define that behavior if you want, so that it has a certain behavior. Let's see, I'll go into a little more detail about some of these, but just to get them all on the table here. Lists. So lists are enclosed in square brackets. There is a similar thing enclosed in parentheses called a tuple. Lists and tuples behave very much the same. Tuples cannot be changed. So you cannot add things to a tuple or remove things from a tuple. There are some protections preventing you from modifying things in a tuple, though not always. Yeah. Lists, on the other hand, you can change wholly. You can remove things and add things at will. You'll notice that you can put different Python objects of different types into lists and tuples. There's just no restrictions on that. You can put anything into a list, anything into a tuple. There are dictionaries, which are a mapping type. So here we're making a mapping from a label to a value. The labels are called keys. So from a key to a value. And this is really like, am I missing anything, Carol? I think this is like the core set of built-in Python types that you'll run into all the time.
Maybe sets, but these are the fundamental ones.
Yeah. So let's look into these a little bit. Strings. Strings are sequences in Python. So I can do things like slice them and index them. Unlike our grids from earlier, these things coming back from these slices are copies because strings are immutable in Python. But that's an exception, not the rule in Python. There's also a whole host of cool things you can do with strings. They have methods for doing like lowercase and uppercase and capital is title case and finding things inside of the string and starts with and ends with for testing stuff. Strings are really, really powerful in Python. So if you work with string data, I think you'll be very happy with Python's ability to work with strings performantly. Lists and tuples. Similar to the slicing we've seen already, and I demoed this earlier. There's only 5 things in there. First 2 things, for example. And again, you can add things to a list with the append method and say add 16. There it is. You can insert things, you can find things, you can remove things. Length, oh, that's a good one. This works on strings too. The len function gives you the list. This works on strings. Len works on strings, tuples, dictionaries, almost any kind of sequence that you can think of. Having a list has this implemented. But not that. And then, okay, so let's do the dictionaries. So to retrieve something from a dictionary, we're going to use the square brackets. I didn't show this with, let me do the list thing real quick. So you use integers to get something out of a list by position. With dictionaries, you use the label to get something out. And there is no concept of getting things out of a dictionary by position. It's only the labels. And then to add things to a dictionary, you can specify a new label. Now it's in there. You can also overwrite any of these using the same syntax. So, any questions about those?
So the first one's the key and the second is the label.
So this is the key and this is the value in the Python vernacular.
The value doesn't have to be just one thing.
Yeah. So Carol said the value doesn't have to be only one thing. Something to point out for lists, tuples, and dictionaries. is that the items can be other containers. So we can think of adding to this dictionary and it can be a complex type. We could put our grids into a dictionary, for example. We could, and this is true of lists. Lists. We could also add a list to a list. In fact, IPython blocks under the hood is implemented as like a list of lists to do the 2D structure. These are being kind of like the core built-in components of Python. All of these things are pretty performant. Dictionaries in particular are very fast at putting new data in and pulling data out. Sort, yeah. So the question was, how do we sort a list? There are a couple ways to do that. There's 2 ways. One is the sorted function, which fails because I have different types in here. But if we did, we would get that back. Or there's a method that you can call. This changes the list in place, whereas sorted returns a new one and doesn't modify the one you pass in. If you're working with purely numeric data, you're going to use NumPy or Pandas or something that is like a tool specifically for that much of the time. Python does have some like basic built-in numerical stuff, and you can certainly use utilities like this. But a lot of the time, you'll be reaching for those more specific tools like NumPy and Pandas for doing purely numeric stuff. But when you want to have a sequence of NumPy arrays or a sequence of Pandas data frames, like you're going to use a list to build that. Or a lot of Python's built-in functions will return lists and tuple-like containers. Do that kind of thing. All right, so any questions about those?
When it returns a numeric value, or when it returns 2, is that a numeric value or a graphic or numeric value?
When
Numeric or string?
Are you thinking of like a specific thing I showed you, or?
When you did the dictionary,
Yeah,
it returned a 2.
yeah, here.
And it wouldn't sort it because you had different types in there. So can you use the dictionary to sort the types?
I don't think I'm fully kind of following your question there. To see if this helps, like this dictionary has these. This is a literal integer, so this is an actual numeric type. When I added like this, you could write a 2 as a string by enclosing it in quotes, and then it would be a string and behave differently than the integer 2. So like, like 2 and 2 are different things. Like, and Python will not try to coerce one to the other if I was to compare them.
And the type function will tell you what kind of type it is.
Yeah. So we can do this. So we got an integer and a string. So I don't know if I'm wholly getting at your question about sorting, but whatever your container, when you're trying to do something like sorting, which requires being able to order the contents, you'll run into this problem if the contents don't have a defined ordering. And see if I can Right? So like Python won't evaluate this because it doesn't have a defined ordering for comparing integers and strings. But you could, if you have a situation in which you have data that's text and you want to convert it to an integer because you know it's supposed to be an integer, like when you're reading a text file, you can use this to coerce to cast the type to an integer. There's int, floats. Those are the main ones you'll use to do numeric casting. Yep. There's also, in addition to this way of converting something to a string, which is not how I would recommend doing it, Python's format strings, did I link to those? That would have been really smart. Yeah. Python's string formatting is super powerful and lets you be very specific about like representing things like floating point numbers, for example, like how do you want to round floating point numbers for output and stuff. So to the degree you can use Python string formatting, I recommend that over doing something like this, because doing this, you get back whatever you get back. For an integer, that's pretty predictable, but for other types, it can be not as predictable. Other questions? All right, so we've only got 12 minutes or so left before lunch. So I wanted to open the floor to questions about literally anything. And also see if, Carol, you had anything you wanted to add at this point.
I would probably encourage you to figure out what you want to try next. I think, like I said before, there's a lot of things that you can do in Python in 5 lines of code or less. You import a library, you like maybe set a couple variables, call a function, and you've got some meaningful results. So you do have like the core of what Python has to offer, and really where you go from here is going to really be dependent on what your use cases are. So yeah, so if you've got specific questions.
You've got the next 10 minutes to ask those questions right now of either of us. You can also stop me at any time during the conference and ask me questions. If you want to actually like have a sit down and set up some time with me during the conference, I'm here until Saturday. And you can send me a note or just grab me. You can PM me on Slack. And I'm happy to sit down with you for an hour and dig into whatever it is you work on, and see if there's any recommendations I have. I may not, because I may not know anything about your field, but happy to dig into it. So yeah, I just want to get any questions from you all about literally like rumors you've heard about Python, literally anything.
Oh, I do want to say one thing. For those of you that might have dabbled in Python in the past and used Python 2, you really want to use Python 3 unless you have a dependency that must have 2. And then you might want to look and find a dependency that takes the place of that. Python 3 is what the vast majority of people should be using, and Python 2 will end of life the beginning of next year. So
Yeah.
and Python 3 also gives you a nice thing called f-strings in Python 3.6 and up, which makes it really easy for those of us that are not great at memorization, like myself, to format strings in a very intuitive way. So I would check out f-strings for output. It really makes your life much easier.
Yeah, so if you installed Anaconda for this tutorial, you installed Python 3.7 in that base environment. You can use Conda, the environment management tool that comes with Anaconda, to create new Python environments. with other Python versions. So without having to reinstall Anaconda, if for some reason you needed to run Python 2, you could use the Conda tool built into Anaconda to create an environment that has Python 2.7 installed, and run whatever it is you need there. I hope you don't have to do that. I'm at the stage of my life where I just kind of pretend Python 2 never existed a lot of the time, which is a nice place to be, to be real honest.
Some things to remember that might reduce your frustration later. Packaging has traditionally in Python been a pain point, for lack of a better word. And partially because Python 2 is around with Python 3, partially because we have a number of different package managers, pip, which is what gets installed with the core Python, CPython, and then Conda, which can be used to install many things beyond just Python. So do not get discouraged if you're trying to set up an environment and like things don't look where they're supposed to look. That's when you find somebody who's maybe a little bit further down the road with you that's done that. But if you can develop within a Conda environment or a virtual environment, if you're using pip, you will save yourself a lot of headaches. And I'm here through Sunday morning, so for those of you that are staying, I'm happy to walk you through that.
We can.
Very quiet.
You guys are so quiet. I can only assume that I did such an amazing job that you have no questions.
Are there any music lovers here? Oh, you had a question.
Actually,
Yeah.
okay, so in your class that you made,
Mm-hmm.
the blocks,
Mm-hmm.
when you called RGB and you printed it, it didn't print like a tuple, it printed the name of the color and some other stuff. But then when you're working with it like it's a tuple. So what's
So you're referring to,
sorry,
I think this thing?
yes, that.
Yeah.
So what it prints that, but then it's
Yeah. I'm going to go under the hood here. This is a really long file because I wanted to keep it all in one file.
And a really good question.
Yeah. Thank you for calling out the magic. So this is the implementation of this. Make that go away. I'm using a really cool thing built into Python called a named tuple, where it gives you can say create a new, this is constructing a new kind of named tuple, create a new named tuple, and it's going to have these inputs / attributes. And the magic of named tuple is constructing a class that has this name and these inputs and attributes, so that we can access them with the .red, .green, .blue, and it makes that pretty display that showed up there. But it also behaves exactly like a tuple, a plain tuple, which is why we can kind of use it interchangeably with a tuple. Like any place I did colors.black, we could have put a tuple with 0, 0, 0 in it. And this is a convenience basically to like enhance that idea of a color triplet with a .red, a .green, and a .blue, if for some reason you wanted access to those. And it makes it helps with the labeling and ordering of the colors so that when you print it, it shows you which one is red, which one is green, which one is blue, and so you don't have to remember the ordering and so on.
But you could still change red by using index 0 or something?
So tuples in Python are,
Well, I guess I can change it.
yeah.
But and there's no like list version of this?
There's not a named list in Python that I know of. You could certainly write your own. if I was to write this for, well, and the reason for that kind of is like, if you were to, I don't want you necessarily, like, as the designer of this library, editing the colors in that particular dictionary, right? Because yellow is yellow, and like, if you change the colors inside of that, it wouldn't be the same color anymore. But if I was writing this in Python 3.7 and wasn't supporting older versions, I would use something called a data class for this, which would be a different way of having the same kind of container with the labeled attributes for red, green, and blue. But you would maybe I could implement it such that you had the ability to change those values if you wanted to. You still look puzzled. Do you have another question?
I'm just like,
Well, and to make it even more confusing, or maybe clearer, I don't know, when you are writing a class, you can actually specify in a function like a repr, R-E-P-R, what gets displayed back to people. So you have some control as the developer on what you display back. But that's, to me, that would be like intermediate plus Python. So,
Yeah, this is a great question, and the kind of thing I'm happy to go into more later. If you have like a specific use case where you're wanting to like have something like this or anything, happy to get into it. And I don't just mean like happy, I mean I would be freaking delighted to like sit down with you and work on a problem. Totally make my day.
can I do a plug for one of my favorite libraries? One of my favorite libraries is a library called Music 21, and I use it a lot and have since probably 2013 with folks that are new to Python. It's a music theory library, but you can actually create music within it, and the gentleman at MIT that developed it, his premise was you can do lots of things in 5 lines of code or less, and it's a good way to kind of play around with something that's not too heavyweight, but you can do some powerful things if you really like music as well. And he's got a whole website devoted to it, so I highly recommend it if you're into music. And for those of you that want like an inside scoop on Python and kind of what the Python community is about, if you type import this and then execute it in your notebook, it will bring up something called the Zen of Python, which are some goofy rules that got made up a long time ago, but they're actually really pretty good things when all else fails. So, but yeah, thank you for learning Python.
Yeah, you see this referenced in like, I won't say arguments, but discussions about like how to implement and design something. People will be like, well, the Zen of Python says this, so I think we should do this thing. It runs deep. Yeah, thank you everybody. We're at lunch. Have fun.